Okay, so number 8, it says find an nth degree polynomial function with real coefficients satisfying the given conditions. It tells me that n is 4, which means it's a 4th degree polynomial, which means it has 4 zeros. It's going to have a 4 is the largest exponent, so x to the 4th will be my largest term. It tells me that I and 3i are zeros. Well, we just said that there are 4 zeros, but they only have 2 listed. So, we got to remember though, imaginary numbers come in conjugate pairs. So I'm going to list out my zeros over here. And it tells me that I is a 0. Well, if positive I is a 0, then so is negative I. The sign in front of the I will just change for conjugate pairs, and imaginary numbers always come in conjugate pairs of zeros. Alright, they also told me that 3i was going to be a 0, or is a 0, and therefore we know because of imaginary numbers coming in conjugate pairs, so is negative 3i. So then we're going to write these as factors. And with factors, we're just putting them back in the parentheses with x. So we can look at it 2 ways. When we take something away from the x, we always change a sign, so when we put it back, we got to change the sign again. Or we can think of it as these are all zeros, which are x-intercepts. That means like x is equal to I. And if x is equal to I, if I want to put it back with x, I'm going to subtract it, and so I would get x minus I in that case. And so that's why it really does change signs. But so the I is going to give me x minus I. The negative I, if I move it over, it's going to give me x plus I. Positive 3i would give me x minus 3i. And negative 3i is going to give me x plus 3i. Now, so I'm going to rewrite this, though, in my factored form, which means I'm going to take f of x equals a and put it at the beginning. A is going to be the vertical stretch or compression or shrink, but we don't know what a is right now. But let's not worry about it. We'll come back later and find it. So what I'm going to have to do now, I'm going to go ahead and just rewrite my factors, actually. And now what I'm going to do is I need to multiply those factors together to get some polynomial form here. Well, we're going to group them. There's 4 of them. Which ones do we multiply to which? You always want to multiply your conjugate pairs together. And that's because with conjugate pairs, the middle terms will cancel. So I know for sure I want to multiply those 2 together and those 2 together. So I'm going to bring down my f of x equals a. X minus I times x plus I. I'm just going to do FOIL. So I get x squared plus ix minus ix and then minus I squared. When I do FOIL for the x minus 3i, x plus 3i, I get x squared. I get plus 3ix minus 3ix, and then negative 3i times positive 3i is negative 9i squared. So I'm just going to simplify what we have in parentheses here. So as first, I'm going to combine those like terms there, so it's going to cancel. So I get x squared minus, and we know that I squared is equal to negative 1. And then I have x squared in the second factor here. 3ix minus 3ix cancels. So I have minus 9, and we know that I squared is negative 1. So it's going to be times negative 1. Now I'm just going to keep simplifying here. So f of x equals a times, we have minus a negative there, which is a plus, so we get x squared plus 1. And then here, on the second one, we have x squared. We have a negative 9 times negative 1, which is a plus 9. And once we got those separated individually, then we're going to go back, and we got to do FOIL one more time with them. So f of x equals a times, when I do FOIL, we get what, x to the 4th plus 9x squared plus 1x squared plus 9. We combine those like terms. So f of x equals a times, I have x to the 4th, 9x squared plus 1x squared is plus 10x squared plus 9. Now, once you get all that multiplied, then we're going to worry about solving for a. Okay, so to solve for a, we know that f of negative 1 equals 40. So what we're going to do is we're going to plug in that x is negative 1, and our f of x is going to be 40. So we have 40 equals a, and everywhere I have an x in the parenthesis here, we're going to plug in a negative 1. So negative 1 to the 4th plus 10 times negative 1 squared plus 9. Alright, simplify. So we got 40 equals a times negative 1 to the 4th is 1, plus 10 times negative 1 squared is 1, plus 9. And then I'm just going to simplify right here with it. We know that 10 times 1 is 10, so I'm just going to put plus 10 up there. So let's add up what's in the parentheses. So 40 equals a times 20. So divide by the 20. And we find that a is equal to 2. Well, now that we know that a is equal to 2, we're going to take that information over here, and we're going to go back up to right before we plugged in our f of x and our x. So this equation right here. We're going to take both of them up here, and we're going to work out our final answer. So we know that a is 2, and we know f of x is equal to a times x to the 4th, what was it, plus 10x squared plus 9. And so we're going to plug that in. So f of x equals, we said a was a 2, so I'm just substituting it in. And then we're going to distribute it through. So we come out with f of x equals 2x to the 4th plus 20x squared plus 18. And there's my polynomial that has zeros at I, negative I, 3i, and negative 3i. It goes to the point f of negative 1 is equal to 40. And it's a 4th degree polynomial. Uh-oh, and I messed up there, right there. Should have been x to the 4th. I just miswrote it. Alright, hope this helps.